Well, for the introduction, the focus of this project is a synthetic leather watch strap, a product designed as a sustainable and ethical alternative to traditional animal leather. And it is made from polymers such as polyurethane. Synthetic leather offers durability, water resistance, and consistent quality, aligning with the growing consumer demand for vegan and also eco-conscious accessories. Second is for our project, it aims to compare three distinct manufacturing methods, which is mass production, batch crafting, and also handmade processes. This is to evaluate their sustainability and practicality. Each method was assessed across environmental, economic, and social criteria to determine which approach offers the most balanced and responsible production pathway. This topic is particularly relevant. This is because today, due to the increasing awareness of the fashion industry's environmental footprint and also the ethical concerns, synthetic leather production avoids issues related to animal farming and deforestation, while offering a scalable solution for brands seeking to reduce their ecological impact. The key question for our project is how can manufacturing reduce environmental and social impact? And what we did to answer this, we conducted a detailed analysis of each production method, examining material sourcing, energy consumption, waste management, labor conditions, and market viability. Our findings provide a clear comparison and actionable insights for manufacturers, designers, and consumers who value sustainability in product creation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal Irfan bin Muhammad Zubir CD230013. Product description: synthetic leather imitates real leather, provide a smooth and neat appearance, easier to produce than genuine leather, suitable for mass production, quality is more consistent. Materials used: main material PU based synthetic leather, backing material polyester fabric, stitching polyester or nylon thread, buckle stainless steel or zinc alloy. Material structure: made from synthetic leather, consists of two main layers: PU polyurethane surface layer, leather like look and smooth texture. Fabric backing: polyester, improves strength and adds flexibility. Manufacturing advantages: easier to cut, shape and stitch. Thickness can be controlled. Produce uniform products. Fewer defects compared to natural leather. Suitable for large-scale production.
Today I'll be presenting chapter 3 of our report which focuses on manufacturing process of synthetic leather watch straps. In this chapter we compare three distinct manufacturing methods, each suited for different production sales and market needs. We look closely at the step-by-step process flow of each method, a sustainability analysis covering environmental, economic and social impacts, and finally which method is best suited for different type of products and markets. Let's begin with an overview of three processes. As you can see, we have three main approach. Process A is roll-to-roll coating and die cutting. Designed for mass production, it's highly automated and capable of producing thousands of millions of units. So the second is process B is sheet lamination and CNC cutting. Ideal for batch or limited edition production, each balances automated with craftsmanship. So the process C is handcrafting from component material perfect for artisan or homemade production, emphasizing customization and sustainability. Follow a continuous automated flow. First, material preparation. Large rolls of polyester fabric are loaded and resin is mixed. And next, coating and curing. The fabric is coated with PU, then dry and cured in a long oven to form a leather-like film. Then die cutting. Custom steels dies cut multiple strap shapes in one stroke, optimized for minimal waste. And then finally, automated stitching and assembly. Machines sew edges, attach buckles, and prepare strap for packaging. This process is fast, consistent, and built for high volume. And now let's look at the sustainability and impacts of mass production. Environmentally, it has a moderate to high impact due to high energy use, chemical emissions, and waste that are to recycle. Economically, it's highly viable. For large orders, cost per step can be less than 2 ringgit thanks to automation and scale. Socially, it creates factory jobs, but they are often repetitive and low skill with potential exposure to chemical and noise. So, where it's excellent for cost and speed, it's come environmental and social traded offers.
Hello doctor, my name is Emil Elisha Moses. Now let's move to process B, batch production, which is quite different. Here we start with pre-made synthetic leather sheets, often from sustainable sources. Next, CNC cutting. Digital templates are used to cut straps with high precision and minimal waste. Then, it is continued with semi-automated stitching. Skilled operators are industrial sewing machine for a premium finish. Finally, we have hand assembly and detailing. Each strap is finished by hand with attention to detail and quality. This method is flexible, sustainable, and ideal for premium products. For process B, the sustainability profile is more favorable. Environmentally, it's moderate. We can use recycled or bio-based materials. Energy use is lower and waste is more manageable. Economically, costs are higher due to skilled labor and premium materials, but it commands a higher selling price in markets. Socially, it creates skilled craft positions in better working conditions, promoting pride in craftsmanship. So, Process B offers a good balance between quality, sustainability, and market appeal. Now, let's explore Process C, artisan production, which is entirely manual and craft based. It starts with sourcing small, often upcycled materials like cork, leather, or old upholstery samples. Then, hand templating and cutting using simple tools like utility knife and hole punches. Next, hand stitching and assembly, where each strap is carefully sewn and finished by the maker. Finally, personalization through engraving, painting, or embossing. This method is slow but deeply personal and sustainable. As we know, Process C has the lowest environmental footprint. Materials can be reclaimed or biodegradable. Energy use is negligible and waste is near zero because scraps are reused. Economically, it's not price competitive, but it creates high value through customization and storytelling. Socially, it empowers artisans, preserves traditional skills, and builds community through workshops and online sharing. It's a model of slow, conscious
Summary
making.
table. Let's compare all three methods side by side. You can see scales ranges from millions to one of pieces. Labor intensity goes from low to very high. Environmental impact decreases from process A to process C. Customization increases as we move toward handmade method. This table helps us choose the right process for the right product. Mass production is the best for high volume, low cost, and fast delivery, but an environmental and social cost. And for batch production, offer a sustainable and premium alternative with good customization and skill product. I mean skill labor. So the artisan production is the ideal for niche personals and eco-conscious markets. Thought is not scalable. However, the choice depends on our priority. That means scale, cost, sustainability, and craftsmanship. That's all from me. Thank you.
Key findings from process comparison. Different processes, different roles. No single manufacturing method is suitable for all situations. Each process meets different needs such as production volume, cost control, and product uniqueness. Process A, mass production, most suitable for large-scale output, provide low unit costs, although limited flexibility in design. Process B, batch or semi-automated offers a good mix of product quality and production efficiency. Market feasibility, process C, handmade, suitable for custom and personalized products, has the lowest environmental impact. Manufacturing strategies and future direction. Suggested production strategy. Use process B as the main production method. Support it with process C for custom order, repair and small modification. Future improvement. Increase use of environmentally friendly materials. Reduce energy consumption in production. Improve recyclability of wristwatch straps. Overall aim to integrate economic performance, environmental care, and social responsibility to support long-term sustainable manufacturing.
Well, for the conclusion, based on our analysis, it shows that no single manufacturing method is universally best, but mass production excels in cost and scale. Batch production balances the quality with sustainability and handmade crafting that leads into customization and also it is low environmental impact. Well, for truly sustainable future, we recommend the hybrid approach which using batch production for main output while supporting handmade processes for custom and repair work. The industry must continue adopting greener materials, improving energy efficiency, and designing for recyclability to align economic goals with environmental and the social responsibility.